Okay, so today we are going to cover the last topic, which is about the confidence interval. So let's see the first question, which says that assume that porosity of coal samples is normally distributed with true standard deviation. So standard deviation is given. Compute a 95% CI, which means confidence interval, for true average, which means you need to find the confidence interval for mean, and it is given, it is normally distributed if the average porosity for 20 specimens, so n is given, sample size is given, and for this sample size mean is given. Yes, so the first concept is confidence interval. How it is defined? So we say that 100 minus alpha percent confidence interval is shown as follows. So if you see this one, it clearly means that 95% means the probability is 0.95 1 minus alpha. So 1 minus alpha is 0.95, but you can write that alpha is equal to 0.05. This is first information. Now how do you compute the confidence interval? So when it is normally distributed, then the confidence interval for mu is given as follows. Now in this one you have x bar, which is given as 4.85, n is given 20, sigma is given 0.75. The only unknown factor is z alpha by 2. So the next question is, how do you compute z alpha by 2? Now what is given is probability of capital Z greater than equal to Z alpha is equal to alpha. So I can say that 1 minus probability of capital Z less than equal to Z alpha is equal to alpha, or probability of capital Z less than equal to Z alpha is 1 minus alpha, which is 0.95. So I need to find the value of Z alpha for which this probability is 0.95, or in this case when we need Z alpha by 2, it becomes alpha by 2. So you can write alpha by 2 is 0.025, and that's why 1 minus alpha by 2 is 0.975. So we will see from the table that how does it looks like. So this is what we are looking for. Now as I have already told, 1 minus alpha is 0.95, alpha is 0.05, and that's why Z alpha by 2, which means Z of 0.025. So probability of Z less than equal to Z alpha, which is 1 minus 0.025, which is 0.975. So in the table you need to see this Z alpha by 2, for which this probability is 0.975. Now if you see the table for standard normal distribution, then you need to identify this number 0.9750, and it corresponds to 1.96. It means that your Z alpha by 2 is 1.96, n is already given, x bar is given, sigma is given. You substitute both the values and get the required interval. So this is how you compute the confidence interval. Let's see the next part. So it says that how large a sample size is if width of the confidence interval is 0.40. So we already know how to find the width. If your interval is minus a to a, or if interval is ab, then here the width is 2a, here the width is b minus a. So we already know the confidence interval, therefore the formula for the width would be like this. Now width is given, Z alpha by 2 has already been computed for 95% interval, sigma is known, you need to find n. Do this computation by yourself and then verify the answer. N comes out to be 55. A similar question is there where again it is saying that the average porosity is within this range, which means your interval is minus 0.2 and 0.2, which means the width is 0.4. Now using the same formula, the only difference is now it is 99% confidence interval. Yes, it means your alpha by 2 is 0.005. Please from the table try to compute by yourself what would be Z alpha by 2 and then find the value of n, and then you can verify from the slides. Now this question is in the tutorial sheet. Everything is same as in the previous question, so that's why I am not discussing it much. You have to find the 95% confidence interval. Z alpha by 2 already know for this one. You have given x bar, you have given standard deviation, this is your x bar, you have given the sample size which is 50, and you need to find the confidence interval. So the similar exercise, the only one thing is there is a point that do this interpretation. So when you find the confidence interval and it is a 95% confidence interval, it means you are 95% confident that the mean would lie in this range. The next part, again you have given the width of the interval and you need to find n, which has already been discussed in the previous question. So try it and then verify the answer. The next part, you have given a data and you need to find a 95% confidence interval for true average degree, so which means for the mean. But one quick observation is here it is not given that it follows normal distribution. The other observation is that the sample size is quite small, it is n is equal to 17. Now when such thing happens, then you don't have to use the previous formula which is based on normal distribution, but you need to see that it can be modeled using t distribution when the sample size is small. And that's why instead of Z alpha by 2, the formula becomes x bar minus s by root n t alpha by 2 comma n minus 1. So you need to find t alpha by 2, so t 0.025 and n minus 1, which is 16. Now this is straightforward from the table. In the table, if you see, then there is mentioned v, which means the degree of freedom, and degree of freedom is n minus 1, which means that it is 16. Now for the 16, you need to see the value and you are looking for 0.025. That's why t alpha by 2 comma n minus 1 here is 2.1. Now once you have this information, x bar you need to compute from the data. So you already know the formula for sample mean and sample variance. Please do this all exercise by yourself. Compute sample mean, sample variance, substitute into the value, verify from the values and get the required answer. There is one more question where sample size n equal to 20 is given and it is saying that it is approximately normal. So it is not directly mentioned normal distribution, but approximately normal, and you need to find the confidence interval for mean. So again, when the sample size is small and we have to approximate it, we can approximate it using t distribution. Now for the t distribution, you need to find the 95% confidence interval. So alpha by 2 is 0.025 and n minus 1 is 19. So from the table, see this value and rest you need to substitute into the formula. So this is how it looks like. It is 2.093 and by substituting you get the required interval. So the quick observation is that when you have to find the confidence interval for mean, there are only two approaches. One is using the normal distribution, the other is using t distribution. If it is directly mentioned that it follows normal distribution, use it. If the sample size is very small and you have to approximate it, then do it using t distribution. The next question asks for confidence interval for variance sigma square. So population variance. Now for confidence interval of population variance, there is only one approach, which is using chi-square. So that's why there is no confusion. The confidence interval is given as follows. Now 1 minus, so it's 95% confidence interval, it means alpha by 2 is again 0.025. You need to see what is chi-square 0.025 comma n minus 1. N is 9, so it's 8. 8 represents the degrees of freedom. Again from the table you can see it, but here there is one quick observation, that in this interval it is chi-square alpha by 2 and it is 1 minus alpha by 2. So it means you need to compute chi-square 0.025 comma 8 and chi-square 0.975 comma 8. Both the things need to be computed. So if you see the table of chi-square, then for 8 degrees of freedom you can see 0.975 and 0.025. These two values, substitute into this formula. This gives you a confidence interval for sigma square. If in the question the confidence interval for sigma has been asked, then you need to take the square root. If for sigma square, this confidence interval is perfect. For sigma, take the square root as it is taken here and get the required answer. Again, the next question asks for population standard deviation confidence interval. So this can be again done. Data is given, you know that you have to follow the chi-square. I will directly show you the answer. Please do try it by yourself and then match the required answer. The last question is very interesting. It says that it is not talking about any distribution. It says that out of 143, 10 are found defective. Calculate a lower confidence bound at 95% confidence interval for the true proportion of such tapes that are defective. Yes. So first you need to see that what distribution it follows. So now what is given is that there is sample size 143. Out of that, how many successes are there? If you relate it, then it is binomial random variable. So here the statistic is binomial random variable with parameter n and p, where n is known and p is unknown. Okay, so you need to find the confidence interval for p. Again, you can recall that for large n, binomial can be approximated using normal distribution, but in this case you simply need to remember the confidence interval, which is p cap plus minus z alpha by 2 under root p cap 1 minus p cap by n. Now p cap means p, which can easily be computed, 10 by 143. Z alpha by 2 can be computed. Once you have these two values, you can get the required interval. So that's all from today's class. Thank you.